Hi, this is Adam from Affinity Energy, and today I wanted to talk about an interesting application we did in solar with a small co-op utility. And we're doing controls for a solar power plant to meet the co-op's needs in their interconnection agreement with their transmission provider. And we're doing controls in a way that I haven't seen them done before. I thought it was kind of interesting the way we did it, and I think it can enable solar to be installed with co-op utilities in applications that they might not have considered before because of limitations they have with their transmission operator. So what we've got is a solar power site that's down the street from a substation where the utility is buying power from transmission. And that substation has one dedicated circuit for the solar site coming into it, and then several feeders that go off into different areas of their service area. The primary requirement that the co-op has is that they are not allowed to export power back onto the transmission system. So therefore, the power coming in from transmission has to be non-zero coming into the site. It can't be less than zero. So they've got a meter that measures how much power is coming in. And then we have a solar site that's right down the street that we have some telemetry. We have a secure wireless connection between the substation and the solar site. And all we're doing is monitoring that meter information to verify what the substation is taking in from transmission. And we have an agreement with the utility. We had to pick some level of minimum power coming in. And if we say arbitrarily, we said 1 megawatt in was the minimum. So it's got to be at least 1 megawatt coming into this substation. From the solar site, we're looking at the meter information, and anytime the incoming power gets to or below 1 megawatt, we start curtailing active power from the inverters at this site. So it's a pretty straightforward control loop to just look at what the incoming power level is and turn down power anytime we get below 1 megawatt. 1 megawatt was chosen so that we kept a reasonable amount of buffer. Because if we set the buffer too low, if we set it for 100 kilowatts and there were a sudden load change, there might be an instantaneous export of power from the substation back onto transmission, and that is absolutely strictly forbidden. So we have to make sure that that limit is never exceeded, that minimum value. Like in most fairly rural areas, from the substation, the typical load, the neighborhoods that are fed, the businesses and commercial areas that are fed from this substation, in this winter and in the summer when there is a heating load or an air conditioning load, the demand is fairly high. So in the middle of summer when we have the most irradiance and the solar site is at its maximum capability, all of the energy that the solar site can generate is being consumed on the load side of the substation. So everything there works great in the summer and it works well in the winter. But in the spring and the fall, when you have less demand for heating and air conditioning, but you still have good irradiance, the solar site's output in the morning and the afternoon before the middle of the day will eat into what would be our minimum allowed 1 megawatt input. So with this simple telemetry system and an RTAC device in our solar site, all we're doing is looking at metering information from the substation and trimming the output of the site in order to maintain the required minimum. This is different than the way it's done with most large utilities, where you've got a 20 or a 40 or a 100 megawatt solar site that's tied directly to transmission. And in that case, their operations center, the utilities operations center, is going to dispatch a command to the site to operate at either 100% output or maybe curtail the site to 50% output. That connection comes from a large operations center that is operated by the balancing authority, and they have the resources and the capabilities of doing that. But with the smaller co-op type utilities, where they're just buying power from an external source and they don't have an operations center where they can figure out how to dispatch commands, we can install a control system at the solar site that just monitors what's happening at their substation, and it takes its corrective actions from a control standpoint without having anybody make a phone call or anything. All we need to do is monitor what's going on at that meter. And this has worked well at a site we have in North Carolina. We've got 3 different solar sites connected to 3 different substations that are doing this, and it's working well. So this might be an approach that would apply to, again, small utilities, small co-ops, or anytime there's really a hard limit that says you can't export power from the substation back onto transmission. So just in summary, a couple of the nice things that work well with this approach is in the summer and in the winter where you've got relatively high demand, you have a low cost source of energy from the solar site that ties in and will allow you to reduce the consumption from transmission. But at the same time, it mitigates the risk in the spring and the fall where demand is low, the risk of potentially exporting power from the substation onto transmission and having penalties or the risk of tripping associated with that. So it's a low cost approach that might enable you to implement some solar power in an area where you might not have otherwise thought it was easy or practical to do so.